All right, for this first example, it says a teacher is buying bags of chips for a grade level picnic. The teacher wants to spend at most, so the key phrase is at most $36. Now, each bag of chips costs a total of $2.95. And it says that the number of bags of chips is X. So at most means the same thing as less than or equal to, because if I have at most something, that means I'm going to have that or less. So the chips are $2.95 each. So we're going to multiply that by how many bags of chips I get, and I can go up to $36. All right, for number 2, it says the graph of an inequality is shown below. Which order pair is a solution? So in order to be a solution, it has to be in the shaded region. All right, so what we're going to do is we're going to graph these and we're going to see which one falls in the shaded region. So I'm going to start with 2, 0. So 2, 0 falls on that dashed line. This is not a solution because the dashed line is not included. It would have to be a solid line. So A doesn't work. So then we have positive 3, negative 1. Well, positive 3, negative 1 is definitely not in the shaded area. We have 0, 0. 0, 0 is in the shaded area, which gives my correct answer as C. All right, so number 3. We have which inequality matches the graph. So when I look at this graph, I can see that I have shading that's going down, and I have a dashed line. So we know we're going to have a less than. And we have a y-intercept at 4. And my slope is going down 1 and right 3. So down 1, right 3 is negative 1/3 x plus 4. Now, if we look at all of our answer choices, those are all in standard form. And since they're in standard form, we're going to have to solve for y until we find the correct answer choice. We cannot decide which one is the correct answer based off of the format that it's currently in. I cannot determine the shading of the graph if it's in standard form. We have to solve for y because the sign may flip if we divide by negative. Now, I can decide, however, though, that these inequality signs that have the equal to's that are going to have solid lines are going to be eliminated. So we're really going to be looking at B and D. So I'm going to start with B, and I'm going to solve for y. So I'm going to subtract x. So I have negative 3x is greater than negative x plus 12. And when I divide by that negative 3, that is going to flip that sign right there. That negative value is going to flip my greater than to a less than. And then I'm going to simplify. So this is actually a negative 1. So negative 1 divided by negative 3 is going to give me positive 1/3 x. 12 divided by negative 3 is going to give me negative 4. And that does not match what I want. So then I'm going to go to D, and I'm going to solve for y there. So I'm going to subtract x. So 3y is less than negative x plus 12. And I'm going to divide by 3. I do not need to flip the sign because my 3 value is not negative. And again, there is a negative 1 there. So I have negative 1 divided by 3 is going to give me negative 1/3 x. And I have 12 divided by 3 is going to be plus 4, which is exactly what I'm looking for. All right, number 4. So for this particular problem, it says that which graph is represented below. So I have 2x, and then I have plus y is less than 3. All right, solve for this particular one so we can determine our graph. So we're going to subtract 2x. So y is less than negative 2x plus 3. All right, so we know with this less than, that means we're going to shade down, and it's going to be a dashed line. Okay, so we can go ahead and get rid of B and D because those are solid lines. And when I look at A is shaded down and C is shaded up. So the only one that could be the correct answer is A. However, just make sure that you check. My y-intercept is at 3, and it's going down to right 1. Very similar question here. We already have this particular graph solved for. We need this to be greater than, and we need it to be a solid line. So we're looking for greater than, so A is less than, B is greater than, and C is greater than. So we can go ahead and get rid of A. We need a y-intercept at 2, and we need a slope that is going up 2 and right 1. Well, we can't go up 2 and right 1 because there's not enough room on my graph. However, I can flip that and go the exact opposite. I can go down 2 and left 1. And because that is a double negative, it'll still be positive. So if we go down 2 and left 1, it still is on my graph. Down 2, left 1. Just like if I had gone up 2 and left 1, it would have essentially fallen right in line. Number 6. It says for number 6 that Stephen graphed the equation y is greater than or equal to x. Judy said there was one mistake in Stephen's graph. Is Judy correct? If so, why? So for this particular problem, we would need to be shading up, and we would need it to be solid. And so without any other explanation, I can see I have a solid line, but he shaded down. So I would have to say that Judy is correct, that there was a mistake, and she was correct that the shading was on the wrong side. All right, so then we have which quadrants should Tommy graph the shaded region? So in this particular problem, I would need to plot my values and then do some shading. No matter how big or how small my shading is, if there is shading in that quadrant, that means that it is a solution area. All right, so I'm going to start by plotting at +5. And my slope is telling me to go down 5 and right 4. All right, so I'm going to go down 5, 1, 2, 3, 4, 5, and right 4. And we're going to make sure that we are shading below and with a dashed line. So I'm going to do my dashed line here, and we're shading below that. So the question is which quadrants have shading? Well, quadrant 2 does have shading right there. Or quadrant 1 has shading, quadrant 2 has shading, quadrant 3 and 4. So all 4 quadrants have shading for that one. All right, so for the next one, it says, what is the most specific name of the quadrilateral for A, B, C, D with vertices? And it gives you this particular points. Now, you can Desmos, you can plot your points. The only reason I say Desmos is a good way to verify is just because if you're plotting with your own grid, sometimes, you can't do perfect sections, so it may look off a little bit. But I'm still going to go for the first option just because we're going to look at it. So I have 1, 1. So then I have 6, 1. I have 3, 5. And I have -2, 5. I have adjacent congruent sides. That's not a kite. So it is a parallelogram, but we want the most specific name, so it may not be that. It is a quadrilateral, but quadrilateral is very general, so that is not the most specific name. So is it a rhombus or is it just simply a quadrilateral? So how do we determine if it is a rhombus? Well, we would need to do some counting and do the Pythagorean theorem and see how long our sides are. So for this side right here, we have this length, and that length is going to be 1, 2, 3, 4, 5. So this is a length of 5. So what I need to do is I want to find this length and see if that is also 5, because if that's 5, then everything across from each other is going to be the same as well. So we're going to start by making us a right triangle, and in that right triangle, we're going to count our spaces. So we have 1, 2, 3, so 3 here, and 1, 2, 3, 4. Okay, so if we do the Pythagorean theorem, we're looking for this side right here. So that's going to be 3 squared plus 4 squared equals c squared. So we're going to have 9 plus 25, 16, equals c squared, which is 25. Well, we're going to take the square root, and the square root is 5. So that means that this side is 5. Well, if that's 5, then that's 5, and that's 5. So they're all the same, which makes this, the most specific name is a rhombus. All right, so I have another quadrilateral, and it gives us these vertices, and it wants to know about the statement. So which statement is correct? So we have parallelogram that is a rectangle, or is it a parallelogram that is not a rectangle? And of course, what is the perimeter? So when I'm looking at this particular problem, I'm actually, I'm gonna kind of split my screen down here, and I'm gonna graph it right here. All right, and I'm going to need to look, and of course if I'm finding the perimeter, I'm probably most likely going to have to do some Pythagorean theorem in order to find the distance. So my first one is going to be -3, 0. And then I have 1, 3. Then I have 4, +2. And then I have 0, -1. All right, and you can definitely see that mine is off a little bit because I did not graph it properly. So if I'm looking at this, and when I say properly, I mean that I didn't space my pieces out exactly like I did the rest of them, which is almost nearly impossible. Okay, so I have this, I can connect them. So I can see that it does have some slant to it, and I would not necessarily say that it is a rectangle. However, you can always graph it in Desmos and see if your pieces are a little bit more accurate. So I think the first one was -3, 0. Then we had 1, 3, 4, 2. And then 0, -1. All right, so when I'm looking at that, I can definitely see that that is not a rectangle. So I would say that this is, we're going to start with, this is a parallelogram that is not a rectangle. So we're going to get rid of A and B. So then the question is what is the perimeter? Well, in order to find the perimeter of a parallelogram, we really only need to find two sides because those opposite sides are congruent. So we need to find this side, and we need to find this side. And then once we know those, we know that the opposite sides are also the same. All right, so I'm going to do the Pythagorean theorem twice. And I'm going to start with this triangle right here. And I can see that there is a distance of 2 and a distance of 3. So we're going to do 2 squared plus 3 squared equals c squared. So we have 4 plus 9 equals c squared, and that's going to give me 13. So the square root of 13 is going to be approximately, so we can go right to Desmos and plug that in. So the square root of 13 is 3.6. And then we also want to find that green side as well. So we're going to make a right triangle there. We have a distance of 3 and another distance of 3. So we're going to do the same thing. So we have 3 squared plus 3 squared equals c squared. So we have 9 plus 9 is going to give me 18. And we're going to take the square root of that. So again, we can go right to Desmos, plug that in. And I can go change that 13 to an 18, and we get 4.2. So this one, this C value is approximately 4.2. Now, the difference is that when I'm looking at this, I need to make sure that my sides, I'm doubling that. Because this one right here is 4.2, and this one is 4.2, so the greens are both 4.2, and my blues are 3.6. So when I add that up to find my perimeter, I want to do 4.2 plus 4.2, or you can do 4.2 times 2, plus 3.6 plus 3.6, and that's going to give me 15.6. So when I add those up, we're going to round that to the most accurate answer, and we got 15.6. So we would go ahead and choose approximately 16. All right, so I have a trapezoid. It says, what is the perimeter? So we're going to add up all those sides. Now, the great thing about this one is I can go ahead and count the distance of those horizontal and vertical lines. We can count spaces if they're horizontal and vertical. So for the top one, I have 1, 2, 3, 4, 5, 6. So that's 6. Then we have 1, 2, 3, 4, 5, 6. 6 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a distance of 10. What we don't have is this distance. So we're going to need to find that using the Pythagorean theorem since it's diagonal. So we're going to do, 1, 2, 3, 4. So we have 4, 1, 2, 3, 4, 5, 6. So Pythagorean theorem is going to be 4 squared plus 6 squared equals c squared. So we have 16 plus 36 equals c squared. And we would take the square root of that. So we have the square root of 16 plus 36, and that gives me 7.2. So that C value is 7.2. So we would need to add up 6 plus 6 plus 10 plus 7.2. So we have 12 plus 10 is going to give me 22, and then 22 plus 7.2 is going to give me 29.2. All right, so for this particular problem, it says, what is the distance between these 2 points? So I have 1/3 and 6 and 15. All right, so 1/3 and 6 and 15. You can plot that. I'm just going to look at it on Desmos. All right, so if I'm counting my spaces, so we are basically, I'm going to take a screenshot and add this. So if I'm counting my spaces here, I have a distance here and here. So I have 1, 2, 3, 4, 5. And then I have another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Missed that. That should be 12. And I can also look at the distance between. So like if I'm looking at the how much between 1 and 6, that's 5. 13 and 15 is 12. So what we want to find is we want to find this distance. So again, we would do Pythagorean theorem. So we have 5 squared plus 12 squared equals c squared. So we have 25 plus 144. And we would take the square root of that. So if I do 25 plus 144, that gives me 13 is going to be my distance. And just remember, if you're plugging your answers in, you only plug in numerical answers. On number 12, so it says, what is the area of the rectangle? So in order to find the area of a rectangle, we need 1/2 the base times the height. So the base and the height are pretty much going to be us counting the spaces, because you're talking about the base and the height. They're both horizontal and vertical. So all we have to do is count those. So we have 1, 2, 3, 4, 5, 6. So that's going to be 6. 1, 2, 3, 4, 5, 6, 7, 8. So we're doing area is going to be 1/2, 6. All right, so if I have 1/2, 6 times 8, that is going to give me 1/2 of 48. and then half of 48 is going to give me 24. So obviously this should have been 24, and it will be on your test or your review when you actually are doing it. That was just a typo mistake. All right, it says, how is finding the coordinates of the midpoint? What is just the x coordinate of that midpoint? So we first need to find the midpoint. So I have 15 and 2, 3 and 8. So I'm adding up my 15 and 3. Okay, so to find the midpoint, we're going to add up our x's, divide by 2, and we're going to add up our y's and divide by 2. Okay, so I'm going to add up 15 and 3 and divide that by 2. Now, I could do my y's if I wanted to, but that's not what the problem is asking. It's only asking for the x. So 15 plus 3 is going to give me 18 divided by 2, and that's going to give me 9. Now, for the next problem, it says the midpoint of the line ST is, so they're giving us the midpoint. This right here is the midpoint, okay? So that's the key. This is an endpoint, okay? They want us to find the other endpoint. So we're going to have to work backwards here. We know the midpoint was 3, 1. Okay, and we know we have this endpoint right here that was used. But what we don't know is the other endpoint. So we're looking for that x2, y2. So I'm going to set my problem up as if I were doing it. So if I had my x's, so I have -3 plus an x that we don't know divided by 2. And I have -3 plus a y that I don't know divided by 2, because we're trying to find that missing point. So what I like to do is I like to split this up. I like to split up so that I have my x equal to my x and my y equal to my y. So I will split this so that 3 equals -3 plus x over 2. And you're going to solve this equation. So we're going to multiply the 2, and that's going to give me 6 equals -3 plus x, and then you're going to add that 3. So x equals 9. So obviously if I look at my answer choices, I can get rid of the other ones. But I just want to make sure we still understand how to split the last one. So 1 equals -3 plus y divided by 2. So we're going to multiply the 2 over. And that's going to give me 2 equals -3 plus y. Add the 3. And y equals 5. So you set it up and you work backwards using your equation inverses. All right, so we have a line segment. And that line segment has one endpoint. So this is an endpoint. And we have a midpoint. What is the other endpoint? So again, same thing, we're going to work backwards here. So we know we have the midpoint, 4, 9. And we are trying to find the other endpoint. So we're going to set this up. So my x plus my second x, we don't know, divided by 2. 5 plus my second y, divided by 2. So we're going to split our x's with our x's and our y's with our y's. So we have 4 equals 2 plus x divided by 2. Multiply that over. 8 equals 2 plus x. Subtract 2, and x equals 6. Look, we can actually go ahead and determine that the answer is B, but I'm still going to show you how to split the other one up. So 9 equals 5 plus y divided by 2. Multiply my 2 over, that's going to give me 18. 5 plus y, subtract 5, and y equals 13. All right, and number 16 says, what is the equation of the line that is perpendicular to, and it goes through this point? So if it's perpendicular to and it goes through that point, then I need to first determine my perpendicular slope. Well, the great thing is this is already solved for. So my original slope is 1/4. So my perpendicular slope is going to be the opposite and the reciprocal. So opposite side, so negative, reciprocal is going to be 4. Right there, I can get rid of C and D. But now what I need to do is I need to write an equation. So in order to write the equation, I need to find my B value. So to find that B value, we're going to plug in our point and our perpendicular slope. So negative 3 equals negative 4 times 4 plus B. So negative 3 equals negative 8 plus B. Excuse me, not negative 8, that's going to be negative 16. Add 16. And B equals 13. So I have my perpendicular slope, I have my B to make my answer y equals negative 4x plus 13. All right, so number 17, it says, what are the pairs that are perpendicular lines? So we want to know which ones are perpendicular. So in order to determine perpendicular, they need to be opposite and they need to be reciprocals. So I cannot determine that unless 1, I graph them, or 2, I solve. So I'm going to go through the solving process because, again, you can check yourself with Desmos, but a lot of these parallel and perpendicular and inequalities, those are going to probably most likely be in the calculator inactive section. So I have 2x minus 3y equals 10. I'm going to subtract 2x. So negative 3y equals negative 2x plus 10. Divide by negative 3. And y is going to simplify and equal positive 2 over 3x minus 10 over 3. Now, for this one, I have positive 2 over 3 and positive 2 over 3. We don't want parallel lines. These are parallel lines. We want perpendicular. So 1 is out. All right, so let's look at number 2. Number 2, I have 5x plus 7y equals 24. Subtract 5x. So 7y equals negative 5x plus 24. And divide by 7. So we have negative 5 over 7x. And then 24 divided by 7 is going to give me 24 over 7 because it's not going to round nicely. So for this one, I have negative 5 over 7, and then I have positive 7 over 5. Those are perpendicular, so 2 is a possibility. All right, so B can't be right because that says 3 only. Well, we know that 2 has got to be an answer choice. So the question is 4 perpendicular? Okay, so these are both in standard form, so we're going to need to solve for both of those. I have x plus y equals 4. And we have x minus y equals 3. So if I have x plus y equals 4, I'm going to subtract x. So y equals negative x plus 4. That means that my slope is negative 1. And then I have x minus 3 equals x minus y equals 3. So I'm going to subtract x. And I have negative y, so I'm going to need to divide by negative 1. And y equals, that's negative divided by negative, is going to be positive 1x. 3 divided by negative is negative 3. So I have a negative 1 and a positive 1. Those are opposite reciprocals, so 2 and 4 are the ones that are perpendicular. All right, so I have an equation of the line. We want it to be parallel, and we have this equation, which if you notice the equation, it is already solved for y. The only difference is the y was in the back of the equation, which doesn't make any difference at all, really. But they want it to go through this point. All right, so if it's parallel, it needs to have the same slope, which all of them do. So the original slope was 4, so the parallel slope is the -4, and this should have been -4 right here. So now what we're going to do is we're going to take that and we're going to plug it into our equation. So we have 10 equals -4 plus -8, and we're trying to find that b value. So we're trying to find our b in this problem. So we have 10 equals 32 plus b, and we would subtract 32. Well, 10 minus 32 is going to give me -22. So we have our b, our parallel slope, which makes the answer b here. All right, well, it's the y-intercept that has to be perpendicular to this equation and through that point. Well, in order to determine the perpendicular slope, we first need to figure out the original slope. Well, we can't figure out the original slope if we don't solve for y. So I'm going to subtract 5x. So 3y equals -5x plus 8. And I'm going to divide by -3. So y equals +5/3x minus 8/3. And really, I don't care about the 8/3. What I care about is the 5/3. I know that my original slope is 5/3, but I want a perpendicular slope. So that's going to be opposite -3/5 for reciprocal. And now I'm going to plug it into my equation. And the reason we want to plug it into the equation is because we want to solve for y. So we have 2 equals -3/5 times -5 plus b. Remember, they're just asking us for the y-intercept. So to simplify this, we're going to take -3 and multiply it by -5. So -3 times -5 is +15. Then 15 divided by 5 is going to be 3. So this is going to be 2 equals 3 plus b, and we're going to subtract the 3, so -1 equals b, which is what they asked for. So if we were plugging this answer in, we would only plug in the -1. We don't put the b equals. All right, so we have a graph of this line, and they want to know which line is parallel to that graph. Well, in order to determine what's parallel, I need to find the original slope. So my original slope, I'm going to find 2 points that are perfect. So I'm going down, so that's going to be -2, and right 3. So my original slope is -2/3. I need my parallel slope, which is also going to be -2/3. Well, my answer choices are not solved for, so we'd have to go through the process of solving and seeing which one has the parallel slope -2/3. All right, so I'm going to start with the first one. I'm going to subtract 2x. So -3y equals -2x plus 9, and I would divide by -3. All right, so a -2 divided by -3 is going to be 2/3. So right there, it's positive. A can't be right. So the next one is 2x plus 3y equals 9. So we're going to subtract the 2x. 3y equals -2x plus 9. Divide by 3. Y equals -2/3, because we would simplify, x plus 3. That is the same slope, so the answer is B. All right, so then we are doing sequence. All right, so for this particular example, it says that Xavier shows the number of minutes that he studies math each day of the week. So we have this pattern, and it says it wants us to find the function that would give us the number of minutes on the 7th day. So we need to write an explicit formula. So an explicit formula means we want to explicitly find that term, so the 7th day. So in the video, you learned about the Deno method. Dino, Dino. The deal is that the D and the I stands for difference. So what is the common difference between your pieces? The N stands for the N in the formula, or technically we would do X. It means your variable. And then the O stands for what is the original number if we had a zero term. So what is that initial value? All right, so when I'm looking at this, I can see that between each one, we are adding by 6. All right, so our common difference is 6. That's what the DI, the difference, stands for. And then we have the N, or the variable. It could be X. And then what would be the initial value if I went backwards 1? So this is the first term, second term, third term, fourth term. We want the zero term. So if we went backwards by 6, so 11 minus 6 would give me 5. So plus 5. So my linear formula for this sequence is 6x plus 5. All right, so given this sequence, what is the numbers that are missing? So we're missing the third term and the sixth term. But I should be able to determine that we are adding 3 each time. So between these two, we're adding 3. So if I add 3 to 7, that's going to give me 10. And if I add 3 to 16, that's going to give me 19. So answer is D. All right, so another example where they're asking us to find the actual formula or the function for this problem. So it says that they gave us the number of coconuts harvested from a grove. We have 14, 30, 46, and 62. They want us to write the function. So again, we have that Dino method, however you want to pronounce it. So I have my common difference. So if I'm looking here, I should be able to see that my common difference between each one is we're going to be adding 16. So my common difference is 16. Then we have the N. The N just stands for the variable, so 16N. And then finally we have the initial term. So the initial term is what would I have if it was term 0. So this is term 1, 2, 3, and 4. So they want us to go backwards and find term 0. Well, if I'm at 14 and I subtract 16 from that, that's going to give me negative 2. So minus 2. So the answer there is going to be C. All right, so the 12th value of the sequence. So you have 2 options. You can actually do this piece by piece and work backwards to the 12th term, or you can do the Dino method, and determine the formula and actually plug in 12 for that term. So again, common difference here. You can see that we are actually going down each time. So the common difference for this one is going to be negative 7. Then we have our N, that's our variable. And then we want the initial term. So that initial term is what would we get if we went back to term 0. So if I'm working backwards here, and I would add 7, and if I added 7, that's going to give me 96. So plus 96. Now, once I've got this all set up, I can just take 12 and plug it in for the term number. So this would be negative 7 times 12 plus 96. So negative 7 times 12 is going to give me negative 84 plus 96 is 12. Or if I realize that I'm doing minus 7 each time, I could keep doing it until I do 12 terms. So again, just to make sure we understand what 12 terms mean. This is term 1, 2, 3, 4, 5, 6, 7, and I have to keep going until I got the 12th term. All right, and it says line L is parallel to the line of the equation of the box. Which could be the line? So we want one that's parallel to this equation. Well, we can't have what type of slope I have unless I solve. And once we know the slope, we want it to be parallel, which should be the same. So I have 4x plus 3y equals 5. So I'm going to subtract 4x. So 3y equals negative 4x plus 5. And divide by 3. So I have negative 4 over 3x plus 5 over 3. So my original slope in this problem is negative 4 over 3. I want the parallel slope. So my parallel slope is also going to be negative 4 over 3. The only answer choice that has negative